Take 3. Okay, so we're talking about gases today. Somebody tell me. Cale just gave me a description of gases. He said the molecules are spread far apart. Okay? Isa?
I was going to say that they move rapidly.
They move very fast. Gases are far apart. They move very fast. They don't interact with each other. Okay? Water molecules touch. They're rolling over each other. Salt molecules still move. They're still touching. They just don't roll over each other. But gas molecules are all over the place. Okay? So, gases take up space. Yes? Did you ever play in the bathtub and you had cups in the bathtub and you turn the cup upside down and put it under and there'd be an air bubble in it? And then you'd let the air bubble out? Or, you fart in the bathtub.
Yeah.
And the gas comes out. Gas has volume. It takes up space. Okay? That's one of the things that we're going to talk about. Gases have a lot of energy. Okay? Gases have a lot of energy. They move randomly in all directions. They have a mass. Okay? This is the kinetic molecular theory that we're talking about. All right? Today we're going to investigate a couple different... Okay, I did hit record. It's not take 4, I promise. We're going to look at 4 relationships, okay, in the lab. Pressure. Somebody tell me what pressure is. It is a force pushed over an area, right? Okay, if I'm pushing on the wall, I'm putting pressure on the wall, right? If you are bleeding, they tell you put pressure on the wound, right? Okay? So pressure is a force. Now, you just told me gas molecules are moving all over the place. Do they run into the side of the container?
Yeah.
Yeah. And when they hit the side of the container and bounce back, they exert pressure. Okay? So gases exert pressure. Volume. We just talked about volume. Temperature. What happens if you heat a liquid?
Bubbles and evaporates. Releases energy.
It doesn't release energy. It takes the energy in. It's endothermic when you heat a liquid. But what happens to those particles in there?
They move back and forth.
They move faster and faster, and eventually they begin to escape and become a gas, right? They begin to boil, vaporize, become a gas. So what can you tell me about the temperature of gases versus liquids?
Are they higher?
They're higher. Okay? And then the number of moles is talking about the number of particles. Do you think that makes a difference, the number of particles that you have if you're talking about a gas sample?
Yes.
You've all blown a balloon up. Let's see if I actually have a balloon, and look at that, I do. Balloons stuck together. You've all blown a balloon up. Why did it get bigger?
Pushing it.
I added, there's more pressure. I added particles. I blew into it. Now, if I tie it off, are the number of particles in there going to change?
No.
Not right away. How could I make it bigger?
Add more air.
I just tied it off, though. I don't have that option. Huh? Heat it. You can heat it. Okay? So we can change the temperature of it, and that will affect the volume. We can change the pressure on it. If I push on it, what's going to happen?
It might pop.
It might pop. I don't like balloons. I don't want it to pop, so I'm not going to pop it. So that is what we are going to do today. I'm going to pass out this assignment to you. So, Mr. Substitute or Mrs. Substitute, please pass out the combined gas law labs right now. Here, I'm going to give you one for Pam when he comes back. Okay? And I'm going to give you one for Seth when he comes back. Or I guess Seth's up there. Oh, yeah. Yeah. 1, 2, 4.
I'm sorry, I had to say that. Oh my God, she's recording.
Okay.
She wants to, so. Let her be.
Our first thing that we are going to do combine gas law. That's what you want. you going to open?
Wait, no.
You have to do
Is it
two
still
separate
recording?
things.
Can you watch?
Yeah.
Oh my god.
Yeah. Yeah, I heard. What are you gonna do? Okay.
Wait, how long is it?
5 minutes.
No, you're taking it. It's nicotine longer than 35.
Okay. So, are we listening?
Yeah.
The first thing it says to do is set up the micro vacuum. You guys know what a vacuum is?
Yes. Cleans my room.
It cleans your room. Do you know how it works?
It sucks stuff up.
It sucks things up, except for science never sucks. There is no such thing as suction. It's just low pressure. The vacuum has a fan in it. The fan blows air out the back. Nature hates empty space. The air rushes in to replace the air that's been blown out the back, and it picks up dirt particles. Okay? So a vacuum is empty space. This is a bell jar. Can you guys see that? Can they see it on the screen?
Yeah.
This is a bell jar, and I have a syringe. Anybody ever get to play with an empty syringe when they were a kid, like in the bathtub?
Yeah.
Okay? You can, that's got a nice plunger there. When you push the plunger in, you push air out. When you pull it back, air will come in. Okay, that's how they get the medicine in a shot. This is not a shot they would give you probably. This is probably from a veterinarian. All right? If I hold my finger over the top and I pull, what happens? I could change my volume, couldn't I? But it immediately went back. Okay? That's because of the gas in there, or the vacuum. It's actually a vacuum. So what we're going to do is use this to take air out of our microvac. Okay? You're going to, the end of the tubing goes into the plate at the bottom, and then the syringe fits on this T-joint. Now I'm going to need help. Who would like to come help hold this for me? Okay. Thank you, Grace. Does everybody know Grace? Say hello to everybody, Grace. Okay, so you're going to hold this like that. Is that on the screen?
No.
Okay, so you have to walk this way a little bit. Is it on screen now?
Yeah.
Okay, you're going to hold it like that. You're going to evacuate air out. And then you're going to push back in. Did you hear the air come back out the other side? Now, why isn't it falling off the bottom?
The suction.
We've created what inside?
A vacuum.
A vacuum, low pressure. Air around it has high pressure. The air molecules are hitting it in all sides, including on the bottom, and it's holding it up. Watch what happens. Get ready to catch it. When I remove the tubing. Okay? So, that is a micro vacuum. What you guys are going to do, thank you very much, is put a marshmallow peep in. They're party cake flavored.
They're what?
Party cake flavored. So you're going to put,
My grandpa
peep, are you watching?
Yeah.
Into the jar. I should have had Grace stay up here. And you're going to remove air and watch what happens to the peep. Okay? So you'll put the peep in the bell jar. You'll evacuate some air. What happens? You'll write it down. So you will have something written in this box. So you might want to put a little X there or something. Okay? Box number 3. Line 3, you will have something written there. Line 4, continue to evacuate air until you can't get any more change in the peep. And in number 4, you're going to tell me what is the relationship of the volume of the peep to the air pressure. If I removed air, is that high air pressure or low pressure in there?
If you remove it.
Uh-huh. It's low pressure inside. What did the volume do? Okay? You're going to tell me. Then you let the gas go back in, and to do that, you just simply pull the thing out. Okay? Then it says clean the top of the bell jar and stick a suction cup to it. So, every lab group will get a suction cup. Now, why do I want to clean the end? What do you know about marshmallow peeps?
I think it's
They're sticky. Okay? So I'm going to take my peep out and eat it. Mmm. Mmm. How's the suction cup work?
stick it in there and it cleans it.
You stick it in there and you force air out around the edges. So guess what you just created on the inside of the suction cup? A vacuum. Then, this time you're going to want the
Yep, me too.
plate on the top, and you're going to remove the air and see what happens. Okay? So your suction cup works because you make a little vacuum inside. Evacuate the air from the pump and see what happens. Okay? Then you're going to put in a balloon that is partially blown up. I think I have smaller ones than this. Okay? Same story. Okay, all this will be out at your lab stations. And you'll remove the air and talk about what relationship you're seeing between pressure and volume. Okay, that is part one. So we're going to go ahead and do part one, and then we will come back for part two. All right, go ahead and turn to the second page of your lab. Okay, you're going to get a beaker, and you're going to get some water, and you're going to put about 40 milliliters of water in it. Does it have to be exact? No. Okay, the more you put in, we already know that water takes a long time to heat up. The more you put in, the longer it's going to take to heat up. So it's not to your advantage to fill the whole thing up. Okay? Step two, you're going to put the can on the hot plate on high. What's going to happen? It's going to begin to heat up. It's going to begin to heat up. It's actually not going to turn black because we aren't burning anything. What's going to happen to the particles inside with the water that we put in there?
Start moving around and getting faster.
Okay, they're going to start to gain energy, and they're going to move around, and they're going to get faster. Joel, will you go put about 3 inches of water in the bottom of that up to this line, and then put about 10 ice cubes in for me? Okay? So the water is going to begin to boil. As it boils, what does that mean?
Energy.
It's getting energy, but what does that mean when it's boiling? What's actually happening to the water molecules? They're changing from a liquid to a gas. And do gases take up the same amount of space as liquids do?
No.
No, that's the whole premise of a bomb. A bomb is something that produces gases rapidly. Okay? That's the whole premise of an airbag. An airbag in your car, if the right amount of force the car has the right amount of force that acts on the mechanism that produces the airbag, it breaks and that bag fills up with air almost immediately. Okay? Air takes up a lot more space than a liquid does, or a solid. Thank you, sir. So, what's going on right now, or gases, not just air. What's going on right now is these gases are heating up, and at some point we're going to be able to hear them boil. Okay? Once you have them boiling, what you're going to want to do is you're going to pick up your can. Now notice, I'm picking it up from the bottom. If you pick it up from the top, this gets very hard. But you're going to pick up your can with boiling water. What's going to be inside the can at that point? Water vapor, right? You're going to have a can full of water vapor, and it's going to be hot. Joelle just filled this tub up with water and ice. So we've got some cold water now. What happens when water vapor condenses or when it gets cold? It condenses, right? Have you ever had that happen on your car windows? You wake up and it's cooled off and you have a lot of moisture on your car. Condensation. So as this cools off, when we flip it into the tub, the water vapor inside is going to cool and it's going to go from gas back to liquid. Is it going to take up as much space? No. So as it doesn't take up the same amount of space, what will happen to the pressure inside? We're going to find out. Okay? So you're going to take it, once it starts boiling, and we'll hit pause until it boils. Once it starts boiling, you're going to take it, you're going to flip it upside down, and it will crush.
Is that why you have a crush can?
Okay. It's boiling. I don't know if you guys can hear it. Here, we'll put the microphone up to see if you can hear it. You guys can't, but maybe Six Star can. Okay, it's boiling. Here is my tub of ice water. One, two, three. You didn't see anything, did you?
No.
No, that's for them to find out.
Yeah, they'll find out, but the rest of you were impressed, right? All right.
Oh!
Today we're talking about air pressure. We're going to do a can experiment to show how strong the air pressure can be. The idea is these cans have a small amount of water and they're heating on the hot plate so that they're boiling. What we'll do is flip the cans over into this bucket of cold water. The water is at freezing point. When we flip them over, we're going to see what effect air pressure has on the can. So what happened? The idea is while the can is on the hot plate, air is being pushed out, has higher pressure. But when it's flipped over into the ice, the pressure lowers as the water vapor inside the can condenses into water liquid. So the can crushes. And that's the strength of air pressure.
We filled this barrel with a couple inches of water, and we heated it up so as you can see it's like turning into steam. And then we're gonna quickly put this can filled with steam into the bucket of ice water, and it should crush. That's because it's going to go through a rapid phase change where the steam is gonna condense quickly into water vapor, and pressure inside of the can is going to be less than the pressure from the outside, and it should crush. It should implode. Thank you!
Tight. Twist. Twist.
That's hot. You want to hear it? I don't want to hear it.
That's fine. Squeeze.
Should I sign something?
Insurance.
I want a single. Come on, go!
Patience, patience, my child, patience.
Oh no, my God, the stopper is getting pulled in.
Yeah, I'm looking a little bit.
Does that mean it didn't work?
Now, throw some water on it. Yeah, yeah. Oh no, just grab the ice, Ewan, in with your hands. That is so wimpy.
Well, I'm scared that it's gonna blow up in my hands.
Wait, no.
Oh,
Mr.
Abrams, do it.
I think
Yeah.
it's getting
Oh.
concave.
Oh yeah.